So the next data type we're going to be looking at are scalars. So this is one of the most simple data types. We're just looking at single values and recording how they change over time. To start with, we can record a single scalar at a time. In this example, we're just going to look at a sine curve. So on our x-axis, we're just taking steps from 0 to 2 pi with steps of 0.01. That's going to give us complete cycles of the sine curve. We then calculate the sine of all those values along the x-axis, and we create our summary writer in the same directory as before. We give it the same run label. Create our summary writer, and then we access that and we add scalars. So we iterate through all the different values of x and y. So this will give us a certain x value and then the sine of that x value, because we've done all the calculation above. And then we add the scalar. So as before in the last video, we give it a tag. This is just an extra label so we know what metric we're trying to record here. We specify the value, which is sine of the x in our case. So we've got the y, and the global step, which is our x value. Times by 100 here, just so we don't get decimals along the horizontal axis. So let's run that now. You can see we get some logging that's returned, just showing that there's been some events that have been written to disk, and so we've got separate files in that logs directory now. You can see the specific file that's been written to that records that scalar data. So let's go across to TensorBoard. We're going to do the refresh just so we can update that data and get TensorBoard scanning for new data. We see now we've got a Scalars tab that has appeared. So let's click on that. And we can see our scalar plot. It's a sine curve, as we'd expected. We can hover over the chart to get specific values. And we can, if we've got multiple runs, in this case we've only got a single run, we can do extra filtering there to only show data for a specific run. So in that last example, we used a single scalar and we plotted it on one chart. But let's say we've got the case where we've got multiple metrics that we want to plot on the same chart. How do we do that? Well, here we've got 5 arbitrary functions. We've got sine curve, cosine curve, and a few others. And we want to visualize all of those curves on the same chart. So we create our summary writer as before with the same label, same log directory. Here we just iterate through all the different functions. We've got the x value, which was our range from 0 to 2 pi. And then we've got all the values that are returned for each of those x values for each function. Now as we loop through at each stage for each x and y's, we want to add the scalars. So we summary writer dot add scalar. We're going to give it a tag of curves this time. So last time we used sine curve, this time we're just going to call them curves. And this is where you would usually put the value. But in this case, we want to add extra labeling to the values that we're providing. So there's lots of different ways you can pass this data, and we're going to look at all the different variants here. So one variant is to pass a dictionary, where the key is the specific label that you want to add. So this is the first metric, for example. So we've got the sine, and then we pass the value as the value. So we've got key value pair. We can pass multiple metrics through this way in one go. So we've got the cosine, and we provide the relevant y value for that. And then we specify our global step as before, and we're times it by 100 again, so we don't get decimals on that axis. So this single line will add 2 plots to a single chart. Another way we can do it is here we're adding scalars again. We're adding it to the same tag, so it's going to be the same plot, and providing a tuple this time, where the first element of the tuple is the label that's going to be used, and then we pass the value. So that's another way we can do it. We can also provide a list, and lastly, we don't even need to provide the extra label, but this then will show just as the curves plot rather than the curves sine plot. So this is more preferable because you get explicit labeling as to what that line represents. So we should have in total 5 curves that have been added, 2 from the first line, and then we've got 3 others. The last step that we're doing here is if you want to save the scalar values as you're going along. So after we've created and added all these scalar values to our summary writer, we could export the scalars to JSON, for example. And let's run this script now. And we can look at the specific file. So using Python tools, we've got JSON tool, we can visualize this. And it's just a JSON file that has saved all the values that we've passed to the summary writer. We've got so this is for the sine curve, logs typed example curve sine. We've got the timestamp, we've got the global step, and then we've got the y value for the sine curve, which has got all the values that we'd send to the summary writer. That's just if you wanted to keep a record of it. But much more interesting is how all that data was visualized in TensorBoard. So we'd written it to disk with MXBoard. Now if we move to TensorBoard, it's automatically updated, and we have a new plot called curves. So we've still got our sine curve from before, and now we've got the curves chart with the 5 lines on. When you hover over, you can actually see the values for all 5 at once. And we'll see that in the tooltip that appears. This time we've got more runs that have appeared, so we can isolate different runs if we're interested. So we can deselect, let's deselect this curve and a few others, and we can see how that changes on the plots. And we could even isolate a single plot by clicking in the radio button. Another way of getting hold of the data that you're interested in, as opposed to saving it in code, is being able to download from TensorBoard directly. If you show data download links, you'll get a little drop down here where you can choose the run and save it to JSON or CSV. So if we click CSV, we're going to get a CSV download of the data in the plot, which is kind of handy.